find d squared y dx squared at x equals 7, and hopefully we know that this means the second derivative, so we just want to take the derivative a couple times here. Okay, we're going to have y prime equals the derivative of ln x. This would just be like ln u. The derivative of ln u is du over u. Du would be 1 over u, which would be x, plus derivative of 5x squared would be 10x, and then we want to take the derivative again. Before I do that, though, I'm going to rewrite this. This would really be like x to the negative 1 plus 10x. And so when I go to take the second derivative, I'm going to bump my negative 1 out front, so I'll have negative 1x to the negative 2 because we subtract 1, and then plus 10. I'm going to rewrite that as negative 1 over x squared plus 10, and we are looking for the derivative when x equals 7, so we want to find the derivative at 7, so if I plug in 7, I've got negative 1 over 49 plus 10, which if I reduce that would just give me 9 and 48/49ths. So that would be my derivative. Okay, 29, find the absolute maximum of f of x equal x squared minus x minus 2 on the interval 0 to 3. Okay, if you remember this problem, what we are going to do to find an absolute, we have to find the critical number, and then we have to plug both the critical numbers and the endpoints into the original function. So my first step is to find the critical number. Let's find the derivative first, and we have 2x minus 1. So if I let 2x minus 1 equal 0, my critical number will be x equals 1/2. Okay, so for the next thing that I want to do, I want to find f of 1/2, and I'm also going to find f at the endpoints, and these are going back into the original function. So if we put 1/2 into the original function, we get, I have negative 225, but I don't see how that could be. I don't think I have the right answer for that one. If I plug 0 into the original function, I'll get negative 2, excuse me. If I plug 3 into the original function, I am going to get 4, but let me just try this here. I'm going to get 1/4 minus 1/2 minus 2. Let's change them all to 4. So I'll have 1/4 minus 2/4 minus 8/4. So 1 minus 2 is negative 1. Minus 8, negative 9/4, so negative 2.25. There we go. Okay, so when it asks for the absolute maximum, what's the highest y value we ended up with? So the absolute max will equal 4. We don't care where it happens at, we just care what it is, and it is 4. Okay, 30, find a positive value of x that satisfies the mean value theorem for f of x equals sine x on the closed interval 0 to 2 pi. If you remember the mean value theorem, it states that somewhere the derivative will equal the slope. So that's what we're going to be doing. So the first thing that I'm going to do is find the derivative. The derivative of sine x is cosine x. Okay, the second thing that I want to do is find the slope. Please remember that 0 and 2 pi are x values, so we need to find the y values for each of those. And we're going to plug those into the original function. So the sine of 0 is 0. The sine of 2 pi is also 0. So if I find the slope, I'm going to get 0 minus 0 over 2 pi minus 0. That will equal 0. Okay, so we know that somewhere the derivative equals the slope according to the mean value theorem. So cosine x equals 0. And we just need to figure out where does the cosine equal 0 between 0 and 2 pi. And if you draw a unit circle, the cosine is the x value. So where does the cosine equal 0? It will be up here and it will be down here. So my x will equal pi over 2 and 3/2 pi. And there we go. Okay, 31. Discuss the following about f given a picture of f prime, increasing, decreasing, relative maximums and minimums, concavity, and points of inflection. Well, we know in order to do that, we need an f prime chart and an f double prime chart. So that's what we're going to do right now. So f prime, this is an f prime chart, and if we're looking for f prime, we're just going to be looking at where the f prime is positive and negative. So when I do this, I'm just looking at above and below. So the derivative is above the x-axis till I get to negative 2, and then it's still above the x-axis till I get to 3, and then it's below the x-axis after that. So that's what my f prime chart would look like. And then f double prime, if I'm going from f prime to its derivative, I'm looking at the slopes. So that's what we're looking at. So we're looking at slopes. The slopes are negative till I get to negative 2, and then they are positive till I get to 1, and then they are negative after that. So that would be my f double prime. So now if I would like to find out what's going on, let's talk about f is increasing. I'm looking at my f prime chart. F will increase from negative infinity to negative 2, and then again from negative 2 to 3. We do have to separate that because we have something going on at negative 2, and that would be because f prime is positive. Okay, and then we're going to have f decreasing, and that would be from 3 to infinity, and that would be because f prime is negative. Notice I never use the word it because I specifically want to go, what am I referring to? I'm referring to my f prime chart. Okay, maxes are minimums. There is no minimum, so no min, but there's a relative or local, they might call it, max at x equals 3, and that would be because f prime changes from positive to negative. Okay, and that's all about increasing, decreasing, blah, blah, blah. Okay, concavity is the second derivative, so we're going to be concave up on the interval just from negative 2 to 1, and that would be because, now we're to f double prime, so it's because f double prime is positive. Sorry about that, is positive. Okay, and then where is it concave down? Concave down would be where f double prime is negative, which would be negative infinity to negative 2, and then again from 1 to infinity, and that's because f double prime is negative. And it did ask us to discuss points of inflection, and there are actually 2 points of inflection. And those would be happening at x equals negative 2 and x equals 1, and that would be because f double prime is changing signs. And there we go. If we wanted to draw a picture next, that would be our next step, which we're not quite doing yet. Okay, number 32, consider the function y equals x cubed minus 12x squared plus 1. Again, we're finding where the function is increasing, decreasing, concave up, concave down, relative extreme of points of inflection, and justifying our answer. So here we go. Okay, we need a y prime chart and a y double prime chart. So to get that, we do need to find the derivative. So y prime will be 3x squared minus 24x. To find a y prime chart, I do need to get critical numbers, so I'll take that and set it equal to 0. So I'll get 3x, x minus 8 equals 0. So my critical numbers will be 0 and 8. So if I do an f prime chart, put 0 and 8. If I test something to the left of 0 into f prime, I'll get a positive answer. Between 0 and 8, I'll get a negative answer. After 8, I'll get a positive answer, and then I'm going to go ahead right to y double prime as well, get my y, actually that's a y prime chart, not an f prime chart. And then from here, the derivative of 3x squared minus 24x will be 6x minus 24. Once again, let's set that equal to 0. We'll get x equals 4. So if I do a y double prime chart, put 4 on it. If I test a value less than 4, I will get a negative answer. If I test a value larger than 4, I will get a positive answer. So now we are ready to analyze this function. So let's talk about y is... Sorry about that. We'll get y, pushed a button I wasn't supposed to. So we're going to say y is increasing. And I would say it's increasing using my y prime chart from negative infinity to 0, and then once again from 8 to infinity, and that would be because y prime is positive. And then y will be decreasing from 0 to 8, and that will be because y prime is negative. And again, I'm not using the word it. I'm specifically referring to my y prime chart, so I want to make sure people know I'm talking about y prime. Then are there relative minimums or maxes? Yes, there's going to be a relative max or local max at x equals 0, and that's because y prime changes from positive to negative, and then there's going to be a relative min at x equals 8, and that's because y prime changes from negative to positive. And so we have to say which one is which, because if we just can't say, when it says relative extrema, we can't just lump them together. We have to be a little bit more specific. To positive. Okay, so we're done with the y prime chart. Now let's look at the y double prime chart for concavity. So I can say that y is concave up. That will be from 4 to infinity. And I was looking at my y double prime chart to do that because y double prime is positive. Okay, and then y will be concave down from negative infinity to 4. And that will be because y double prime is negative. And then there will be a point of inflection because y double prime does change sign. So we'll have points of inflection at x equals 4. And that will be because y double prime changes sign. So just make sure when you're doing your justifications, you know which chart you're looking at, so you know whether you should be referring to y prime or y double prime. And we have finished all 32 questions. Way to go.